Okay, so this is a short demonstration of how to use Visual Soakaway Design 4. It might be an idea if you click on the full screen button on this video demonstration so you can see the full detail of what I'm going to do. So I start the program and you have an introduction screen which just has a basic disclaimer to say that you must maintain soakaways for them to work properly. So with that we click start and straight away we get into this visual design window. To begin with, I'll do a sample project. I'll give it a name, test project, project number, and date. So this is just information which will be stored in the design file itself if you choose to save it. Okay, so moving over to global variables, you start with impermeable area, and that's the area of the roof or the road which is contributing water into the soakaway. So if we take an example of a basic single dwelling house, let's assume that it's 100 square meters. Next to that is a button called VRC, which is the volumetric runoff coefficient. Now, if you're familiar with storm sewer design, normally you would take that to be 0.75, and this coefficient is basically saying that this is the amount of water which is coming off the impermeable area and coming into the soakaway. So if you had 0.75, that would mean that 75% of the water falling onto the roof will actually make it into the soakaway or the storm sewer system. For soakaway designs, we generally take that as just 1, meaning that all the water falling, all the rain falling onto the roof or the road will eventually make it into the soakaway. You can vary that if you want. You can move it down to 0.9 if that's more reasonable for your design, but let's keep it as 1 for the time being. So OK that. Moving over to rainfall depth. Now obviously this is crucial. You need to know how much rain is going to fall in a worst case scenario in your project and where you're building your soakaway. There's a calculation button here which you can use to further develop the rainfall depth. Now this is based on BRE 365, which is really the UK standard for soakaway designs. So to begin with, you need to know your ratio R for the area that you're developing in. Now the ratio R is the ratio of a 60-minute storm compared to a 2-day continuous rainfall period. So it really is just a factor. Normally what you can do is refer it to the map which is contained in BRE 365 document, and it will give you an approximate map of the UK showing effectively contour lines of where the ratio R values exist. So let's assume that we're developing a soakaway in maybe central Scotland, and it's going to be around about 0.24, and we'll take a 60-minute storm duration. So I click on that and straight away it gives us an M560 rainfall, which is 20 millimeters, and that's saying a 5-year return period of a 60-minute duration rainfall is going to equal 20 mil of rain. And it also gives us an M1060 rainfall, which is a 10-year return period of a 60-minute duration, 23.8. And then if we click over to the Z2 factor, Z2 is the growth factor for the M10 storm. It's basically factoring up the amount of rainfall that you may encounter during the life of your soakaway. So our rainfall is 20 mil, so the M5 is 20. We're developing a soakaway in Scotland, so let's click on 1.19. and it's going to give us this depth here, 23.8 millimeters, which is reasonable for the geographic location of where we are. Now, just one other thing to note: if you go back to the Z1 factor, sometimes designers are being asked to design for climate change. If that is the case, obviously you can take your rainfall duration up to a much longer duration, maybe up to 3 hours, if you really had to accommodate climate change, longer storm durations at higher depths. But for this one I think we'll just choose 23.8, and I can click on use in design, and straight away it puts a value in there. Now you don't need to use that calculation button, that's just something that's recommended by BRE 365. If you have local rainfall data for your site, and you know that you're going to be having no more than 20 mil of rainfall within your project site, then you can use that. You can type in anything you like. You can type in 25, whichever you want. Okay, so moving over to soil infiltration rate. Now this is crucial for any soakaway design. A soakaway is only effective if you have a reasonable soil infiltration rate in the ground. If you're trying to develop a soakaway onto, for example, clay, then it's not a good idea. You might want to look at alternative methods, because clay is very much impermeable, and not much water is going to get through that. But if you're lucky and you have a sandy soil type makeup of following your ground investigation, then you can use that. I have a soil table here which gives you a rough idea of the infiltration rates you can expect for different types of soil. Big warning message on the top says this is just a guide, and it really is just a guide. What you must do is have a ground investigation and a soil infiltration test done in the location of the proposed soakaway. So I could use one of these. I could say if I'm lucky enough to have sand in the ground, I could click on that to use in design, and it will give me that value into there. But I'm going to delete that for now. I'm going to click on Calc. Now, if you've done your soil infiltration rate calculation, what you have to do is have a trial pit of approximately 1 meter in length by 1 meter wide by 1 meter deep. And what we're doing is, for this test, you fill the trial pit full of water, and you monitor the level dropping from 75% to 25% of the effective depth. So let's say it's 90 minutes in this case. I can click on Calculate Infiltration Rate, and it will give me the value in here. It gives me it in this scientific notation. It's basically saying 3.08 times 10 to the minus 5. It'll accept that as a valid number. Okay, and over to storm duration. I'm going to say it's a standard 60-minute storm. You can take anything here. You can actually type in your own storm if you want. You can say 75 if you want to type in an actual value, but I'm going to stick with 60 minutes in this case. So there we have all of the global variables that we require for our soakaway design. Now, the way the program works is you have to put in a nominal design initially to get it started, and then after that it will design in real time. So I'm going to expand this window slightly. There we go. And I'm going to say, okay, length, let's say 1 meter by 1 meter deep by 1 meter wide. Okay, now straight away it tries to give me the best design possible, but it needs a bit of human interaction. It's giving me a big wide soakaway. So what I'm going to do is, with the little spin button here, I'm going to take the width down. Now you'll see that as I click these buttons, the numbers change. Obviously the width goes down, and then it redesigns the length. Now what it's doing is it's designing in real time. It's actually designing the soakaway as I change the values. And what you also have over here is a split window. You have a cross-sectional view of the soakaway with grip boxes, and these grip boxes allow me to stretch the soakaway, and it will design, as I say, in real time. And over on the 3D window, we can actually get a 3D representation of the soakaway, which again will change size and shape as I design like this. So you can either change the cross-sectional area of the soakaway with the grip boxes in this window, or you can come over to the numbers and you can click up or down, and it will redesign as you go. Now we're seeing this design is going fairly well, because the half-empty time is showing as 1.39, which is good because we want the half-empty time to be less than 24 hours. That is a safety check for soakaways, and in their designs what you have to do is make sure the soakaway will half-empty in 24 hours, basically in preparation for another storm of a similar duration coming along the next day. So we're well within normal parameters in this case. So have a look at the 3D design window. This is really just a 3D representation of the soakaway. In this case it's a trench soakaway, and it's a big rectangular shape, and you can see the incoming pipe on the other end. Now this blue band around the side is basically saying that we're only considering half of the effective depth as being a surface whereby water can exfiltrate into the soil. Okay, now that's just a band around the soakaway. Most soakaway designs do not consider the base of the soakaway to be a surface for for allowing water to pass through. Now obviously it will pass through, but what we're saying is that in some soakaways the base of the soakaway will become clogged with silt and vegetation in a relatively short space of time. Now you can override that. You can actually set the base of the soakaway to be allowable for exfiltration into the soil, and we do that by the design options. I'm going to click on this button here, this little tool set button. Okay, and we can see include base in trench soakaway calculation. I can click on that. It'll show me that it's going to include it, and if I click OK, then it shows a blue block on the base of the soakaway, so it's saying that's where the water is going to escape out of the soakaway. Now I'm going to skip back to design options because there's a lot happening in here. Only one option for designing of trench soakaways. You can switch on the base or off. But there's other variables down here. Factor of safety. This is taken from the Syria 156 recommended document for soakaway designs, and normally defaults to 1, meaning if there's a failure in the soakaway, then there's no real risk of property damage as a consequence of that failure. But you might have a soakaway in a location where there is adjacent property, and the consequences of that failure could be severe, so you can actually start to push up the factor of safety, and the colour of the text will change and eventually go red if you're in a very tight site area. Now what this factor of safety does is it takes the soil infiltration rate and divides it by the factor of safety. So effectively we're creating a bigger soakaway depending on this factor of safety. Okay, and it goes all the way up to 10. There we go. So in this case we're going to assume that it's a factor of safety of 1. If the soakaway does fail, let's assume it just overflows into a field and it's not that bad. Now what you also have is a void ratio. Now the void ratio is basically the infill material in the trench soakaway, and using normal hardcore stone material you normally get voids of about 30%, so that's 0.3. So 30% void ratio. Now some people design using storm cell style units, which are the high void ratio plastic sort of baskets, effectively made by Hydro International, I believe. And what they do is they actually give you a very high void ratio, sometimes 0.9. I think 90% void is a fair void for these type of units. So if you are designing using storm cell units, you can put that up to 0.9. That will massively reduce the size of your soakaway if you're using that style of design. Okay, so we've looked at the design options. Now, what we're doing here, we've included the base in this soakaway. Now, it's worth noting as well that it is okay to include the base of the soakaway in your design, providing you have a silt trap manhole before the trench soakaway, and that's going to capture a lot of the silt and suspended solids and vegetation before it enters the soakaway. So that's generally a good idea in any soakaway design. Now, the program will also design for a precast concrete ring soakaway, so I'm going to skip over to here, and here we go, and we can see a precast concrete soakaway. Now, it's not a very user-friendly shape here, so let's change the size of it. And what we've got here is standard sizes of ring size. Most concrete ring soakaway manufacturers will provide standard size of concrete rings. These are similar to manhole sizes in sewer design. So you have 900, 1050, 1200 up to 2.7 diameter. So you can click on any of the rows here and it will design the depth for you. Okay, so we're seeing the depth for this design for a 1350 ring. The depth can be 1.5 meters. Half empty time is way below 24 hours. It's 3.04 decimal hours there. So again, we have a basic 3D representation of the soakaway, and here we go. We have the soakaway itself, and again we can actually vary the diameter of the soakaway. We can do a variable ring design. If maybe the size of ring that you want to design for is not one of these standard sizes, you can actually vary this size like I'm doing right now. Okay, but I'm going to stick with a standard size. I'm going to say 1350. Now, in the design options, there are other options you can apply to your precast concrete ring soakaway. I'm going to click on this and go to ring soakaways. So, obviously, you've dug your trench to put your soakaway into, but it's not going to be circular. It's impossible to dig a circular trench. It's going to be square, probably. But what you can actually do is include the granular fill area around that square hole that your soakaway sits inside. So what you can say is, I can say maybe I want 300 mil of a margin around that soakaway in my trench that I'm going to include in the design, which is a reasonable thing to do. You've dug out that excavation and you want to make maximum use of the area that you've actually dug out. What you can also do is include the base of the ring soakaway in the calculation just by switching that on and off. Again, depends on your design. Do you have a silt trap? Do you want to include it? It's entirely up to the designer. And also in ring soakaways there's a failure depth, and in this case the failure depth is 4 meters. Any deeper than that, and really you need to be looking at other options. But you can vary that. I've included this just as an option for some designers to increase or decrease as required. Now, what we can also do is we can also say that this soakaway we're designing is actually a filter trench. So it's basically like a soakaway with an outfall coming out of it, and generally used where you're trying to minimise the impact of a storm sewer system on adjacent watercourses, rivers and lakes and that kind of thing. So if you wanted to provide a bit of attenuation and hold back that water and have most of it soak away into the soil, but then in high storms maybe you want to have an overflow which will take that away into the watercourse. Quite a common thing to do these days. Certainly the environment authorities are quite keen on attenuating as much of the water as possible. So we can design our soakaway as a filter trench, and what you can say is, okay, I want to have 10% of my of the water overflowing into the watercourse, and that means I'll be retaining 90% within the soakaway. Okay, and what you can also do is half empty time. We can vary the half empty time if we want to. It defaults to 24 hours, and I would strongly recommend that you keep it at 24 hours. But this value can be changed if you really want to. If you want to vary it up or down. Okay, so that's all the design variables. Now, if you set something that you're not sure about, you can click on Restore Defaults, and it will restore all the default settings if you get concerned that you've changed something that you shouldn't have changed. Okay, so I say OK to that, and there we go. Now what we did here is I specified a margin around the soakaway as granular fill area that we can consider in the design, and that's what this line drawing is showing. So if I click back to my 1350 ring, you can see that the depth before was 1.5, now it's 1.11, and it's given us a lower depth of soakaway, and you can see the diagram. Okay, so we've designed our soakaway. Now what we want to do, obviously, if you've bought the full version, or if you're thinking of buying the full version of Visual Soakaway Design, you have the ability to save the project, which I will do. I'll save it here, overwrite that, but you can also open other projects if you want. You can actually open and what I will do is I will just open one right now. There we go, that's our design, and obviously you can create new projects as well. Now, most importantly, we can actually print off the calculations for this design. So I'm going to click on this button here, and it will basically give us a print preview of everything that we've designed in this design. So it gives you your global variables, all of that you put in. It gives you kind of not so much a warning, but information to say that you've included the base in the soakaway design. And what it's going to do is going to give you all the information you need. It's going to give you a precast concrete ring design, and it's going to give you your trench soakaway design as well. Also includes the area of exfiltration. That's the area that's half empty, sorry, the half depth, half the effective depth, plus the base of the soakaway, and all that area added together gives you this kind of total surface area that you're considering that water can pass through into the surrounding soil. And also, just for extra information, if you did design a variable ring soakaway, then it will give you that information as well. Okay, so all of the design calculations conform to BRE 365, which is the main standard for soakaway designing in the UK. There are elements of Syria 156, which is another very good document for Soakaway designs, and some of the recommendations in there include the factor of safety and other options that you can include in your Soakaway. But essentially, the designing a Soakaway is a very simple process. You're basically designing as a storage volume, and the storage equals the inflow minus the outflow. So the inflow is the water coming in off the roof and roads area, and the outflow is the water escaping out into the soil. So essentially it's that simple. This calculation is storage volume equals inflow minus outflow. And there we go, that's a simple Soakaway design by Webcom Systems. And there we go, Visual Soakaway Design 4. If you do wish to purchase the software, you can do so on this website by clicking the buy button at the top of the screen. Thanks for listening.